Hi students, today we are going to discuss the topic exponents. Assume you have been asked to write down 6 multiplied by 6. Remember, you haven't been asked to calculate it. You pick up your pen and write it as 6 times 6. Here we are multiplying 6 by itself just once. Now let's say you have been asked to write down 6 multiplied by 6 multiplied by 6. You write it down as 6 times 6 times 6. In this example, we are multiplying 6 by itself twice. 6 multiplied by itself multiplied by itself. Now you have been asked to write down 6 multiplied by 6 multiplied by 6 and so on 10 times. So now you have kind of bored. You don't have a choice. So you have to write 6 times 6 times 6 times 6 and so on 10 times. Yes, I know what you're thinking. The more number of times you multiplied by a number by itself, the more tedious it gets for you to write it down. So that's bring as a question. Is there an easier way to denote this kind of operations? What kind of operations am I talking about here? The one in which a number is multiplied by itself many number of times. The answer to that question is yes, we do, which brings us a topic of exponents. 6 multiplied by 6 can be written as 6 with a 2 in the superscript. This is read as 6 raised to. How do we get here 2? It's depend on the number of 6 you can see. So we have 2 6 here and hence we write it as 6 raised to 2. In the second case we can see 3 6. Hence it can be written as 6 raised to 2. How do we get a 3 in the superscript? That's because we have here, and in the final example we have 2 3 5 6 7 8 9 10 times 6. We write it this a long string of numbers of 10 6 as 6 raised to 10. If we have any number, say x multiplied by itself many times, we write it as x multiplied by x multiplied by x multiplied by x and so on. If there are n number of x in this product, then we can write it as x raised to n. The number of x is called as base and the number of n is called as exponents. In 3 examples, we saw all of them have a base equal to 6. It is just the exponents that varies. The first case, the exponents was 2. The second case, the exponents was 3. And in the final case, the example, the exponents was 10. In the next, we will look at the different properties of exponents. We saw why we need exponents. If a number is multiplied by itself many times, we use the exponential form. Now, we will cover a few more important points about exponents. One example of an exponent is 100 raised to 10. The number 10 is called the exponents or the power, and the number 100 is called as the base. The power tells us this could equal the product 10 100. Hence we write it as 100 multiplied by 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 100. Similarly, 8 raised to 3 equals 8 multiplied by 8 multiplied by 8. This was very simple, but let's look at an interesting example. What will 7 raised to 0 be equal to? How do we write the product of a number 0 times? So if this cannot be written as a product, does it mean that it's equal to 0? No, the answer is 1. 7 raised to 0 equals 1. Actually, any number raised to 0 always equal to 1, or even 100 raised to 0 equals 1. Surprised? Well, this was an interesting fact about exponents, but what's even more interesting is the logic behind it. We know that 10 raised to 3 can be written as 10 multiplied by 10 multiplied by 10. Similarly, 10 raised to 2 can be written as 10 into 10, and 10 raised to 1 is equal to just 10. Then what will 10 raised to 0 be equal to? Let's go back and analyze a bit. When we came down from 10 raised to 10 and 10 raised to 2, We divide it once by when the power reduced by 1. We divided it once by 10 when we came down from 10 raised to 2 to 10 raised to 1. We again divided by 10. So when we came down from 10 raised to 1 raised to 0. Since you are reducing the exponents by 1, we again divided once by 10 and that's how we get a number 1. Therefore, any number raised to 0 will always equal to 1. Actually, not any number. Any non-zero number raised to 0 will equal to 1. 0 raised to 0. Some mathematicians says is 1. Some say it's 0 and some say it's undefined. But we can surely say that any non-zero number raised to 0 is 1. There are two or more simple concepts we will understand in this video. The first one is kind of intuitive. How can we write 1 raised to 5? It will equal to 1 multiplied by 1 multiplied by 1 multiplied by 1 multiplied by 1, and that it could be 1. In the same way, we get 1 raised to 4 is equal to 1 multiplied by 1 multiplied by 1 multiplied by 1, which equals to 1. Hence, 1 raised to any number will equal to 1, whether it's 1 raised to 100 or 1 raised to 10,000. It doesn't matter. The answer will always be 1. Now, let's understand the other concept. We know that 0 multiplied by any number, it's equal to 0. So, what will 0 raised to 4 be equal to? Well, write it as 0 multiplied by 0 multiplied by 0 multiplied by 0. And since 0 multiplied by anything is 0, this result will also be equal to 0. 0 raised to 9 will also equal to 0. Even 0 raised to 10,000 could equal to 0. So, you could have guessed the property by now. 0 raised to any number equals to 0. Correct? No, that's incorrect. The correct property says that 0 raised to any positive number will always equal to 0. Why can't we have negative powers here? We will see that in our video on negative exponents. Any non-zero number power 0 is equal to 1. 1 power any number is equal to 1. 0 power any positive number is equal to 0. Now we are going to discuss the negative of the powers. Until now we have worked only with the positive exponents. Here a very simple example to understand negative exponents. Consider this number 10 raised to 2 minus 2. Since we are familiar with the positive exponents, let's understand how we can write this negative exponents as a positive exponents. We multiply and divide the number by 10 raised to 2. Multiplied by 10 raised to 2 and divide by 10 raised to 2. In short, we are multiplying the number by 1, which will keep the original number unchanged. That's equal 10 raised to minus 2 multiplied by 10 raised to 2 divided by 10 raised to 2. We multiply this with this and divide by this. Focus on the numerator. Now, since the basis is the same, we can see the product law. We write it down as 10 raised to minus 2 plus 2, and we write the denominator as minus 2 plus 2, which is equal to 0. Hence, that could equal 10 raised to 0 divided by 10 raised to 2. And since we know that any non-zero number raised to 0 equals 1, we can write it down as 1 divided by 10 raised to 2. Let me repeat, this is a very important property. Any non-zero number raised to 0 equals 1. This was our original number 10 raised to minus 2, and we got the answer as 1 divided by 10 raised to 2. So all we did is change the sign of the exponents. We wrote it under 1. So we can generalized it as a raised to minus m equals 1 divided by a raised to m, where a is not equal to 0, because if a is equal to 0, then we could have 0 in the denominator, which could make it as indeterminate. This term is read as a raised to negative power m. There is a very simple trick we need to understand here. Consider 10 raised to minus 2. When we have to write it down as positive exponents, it's equal to 1 divided by 10 raised to 2. So all we did here is change the sign of the exponents and write it under 1. Now consider 2 by 3, the whole raised to minus 4. To write it down as a positive exponents, we write it down as 1 divided by 2 by 3, the whole raised to power 4. Again, we just change the sign of exponents. I write it under 1. The same trick can be used for the positive exponents too. Now consider 5 raised to 4. We can write it down as 1 divided by 5 raised to minus 4. We change the sign of the exponents. I wrote it under 1.